Good morning, everybody. This is Eureka John with Eureka Street Crypto Hub. This is my video blog. Every morning, I jump online and talk some crypto. Try to keep it to about 30 minutes. But yes, this is nothing more than a video blog. This is me in my discovery process, learning about the crypto space right now. This is a learning time of my life. I'm not shilled or paid by anybody to talk about anything. It's just free-form stream of consciousness. And I'm broadcasting live on Theta Television from Leander, Texas. And it is May 14th, 2021 at 5:50 in the morning. So I've been going every single morning since February 6th, 2021. And I've been broadcasting on this channel since October 24th, 2020. And just started from square one back in October. I've been into crypto since 2018, and it's been kind of a lonely space for me because nobody around me knows anything about crypto or generally likes to hear me talk about it. So this is my outlet, and it also disciplines me to learn something new every single day, and it forces me to learn something new, to have something to talk about at all times. And it's been really cool. I've gotten to learn about some really good projects. About every couple weeks, I'll do a long format, project-oriented type of video. I get into fundamentals. I like to explain what a project does and explore what a project does, not necessarily the price action. I don't do TA, technical analysis, and reading charts. Every once in a while I might look at a chart and see if I can find a pattern, but there's plenty of guys out there that do TA. And I'm just not one of them. So I can refer you to a couple people that I know on here that do some good TA, and I'll do that shortly here. Actually I can go ahead and do that now. Let me see here. I just discovered, crypto chemistry is somebody that I like to listen to. And these guys are on YouTube, Crypto Chemistry, and I just discovered somebody new yesterday. Hold on, let me go to my YouTubes, my boob tube. Actually, they're not allowed on YouTube, so it's okay. Let's see here. And if you follow me on Odyssey, I prefer to build an audience over on Odyssey or BitChute because just of everything that YouTube does as far as censorship and they blatantly allow scammers and everything like that. I'm kind of over YouTube, and so let's see here. My subscriptions, let's see here. Where is this one I discovered yesterday? I can't remember the name of it. It's just kind of a standard name. It didn't really stand out to me, but he does a pretty good podcast. Sorry, dude, I can't remember your name. Okay, I like this guy down here, the late adopter. He does some entertaining technical analysis. I'll think of it here, and I'll let you guys know as soon as I find out. So, all right. Well, that being said, let's go over to the CoinGecko, take a quick look. And I know transaction fees have been really high. There's been a lot of controversy going on with Elon Musk and all that stuff. Him pushing back against Bitcoin for not being as green as he wants to support, which I don't know, man. I just did an article, not an article. I did a broadcast a few days ago, I guess last week, and called "You Must Hate the Earth If You Mine Bitcoin," and that was meant with all sarcasm intended. Bitcoin mining can actually help eliminate a lot of these stranded pools of natural gas, and it can help remote communities in that way by providing them an income. It can burn off extra flare gas. I mean, there's a lot of things you can do and a lot of alternate ways you can mine Bitcoin. You can do it through alternative energy sources, and which I believe the number was pretty high of the amount of Bitcoin that is actually mined by using alternative energy sources. So people don't understand or actually bother to research into the bigger picture. They just buy into exactly what Elon Musk has to say at all times. And yeah, hey, what's up, Italo Raul? Nice to see you. Yeah, so so just do a little digging in before you just believe everything that's going on. And right now, this is a perfect time in the market to buy, in my humble opinion. It's an opinion, not advice, and opinions are just like a-holes. Everybody has one. Some smell fresher than others. I don't want to go too deep down that analogy. Literally. No pun intended. Oh, man. All right. So what do we have going on here? Bitcoin at $50,517.16. Ethereum at $3,985.94. Like I say all the time, it's just amazing that we're considering this a setback at 50,000 Bitcoin and 3,900 Ethereum. It's just insane. Binance Coin at 604.30. Doge at 52 cents, up 30.8 cents, despite Elon Musk's news of the dump. XRP $1.39. Cardano $1.88. Tether under $1. Polkadot 41.29. Bitcoin Cash $1,315.05. Litecoin 327.04, and Uniswap 39.83, and Chainlink 45.57. This is considered a Chainlink dip. I bought what I thought was the dip at $48 a few days ago, and I bought a significant amount of Chainlink, and I wish I would have just waited maybe one more day, but you never know what's going to happen. It's okay, you know, coulda, woulda, shoulda. I still think I got a deal on Chainlink. There's a lot of amazing things happening with Chainlink right now, and this is just the beginning for the Chainlink era. And I believe the same thing with Theta as well. So hold on and put on your seatbelt if you decide to buckle into Chainlink and Theta. And what's up with this Clayton? I've been seeing this pop up in the charts, and I need to kind of dig in and see what the hell this is all about. Up 32.7% in the past 24 hours. It's in the past year, it's up 2,742.9%. It's just kind of popped up out of nowhere. Clayton is a public blockchain platform of the leading South Korean mobile platform Kakao, dedicated to validating the value and utility of blockchain technology by providing a blockchain service for mass adoption. Clayton provides an easy development environment and friendly user experience. Clayton seeks to continue advancing the platform to offer blockchain services for millions of users. It will use, so it's not out yet, Istanbul Byzantine fault tolerance. I wonder what the difference between Istanbul Byzantine fault tolerance and Byzantine fault tolerance is. You can read more about Istanbul Byzantine fault tolerance here. Well, why not? I didn't really have like a major specific agenda. I had some general ideas I wanted to talk about. I wanted to talk a little bit about programming languages for various blockchains, because I'm going to be doing some videos for the Komodo Blockchain Academy that they're rolling out, and it looks to be pretty cool. The Komodo team's pretty cool, so I wanted to help them out, and and it's kind of a little bit of cross marketing, I guess, to bring some attention to this show that I'm doing here as well, so it works out for everybody. And I'm going to start with going over let's see here, blockchain programming languages. And I'm basically just going to do a little TLDR, too long didn't read, video of all these articles that are on there. And it should be pretty cool in helping bring people into the cryptocurrency and blockchain fold. Okay, so let's see. Istanbul fault tolerance. Okay. Let's see. What's up, Mary Snape? What you up to this morning? Yeah, well, I don't know if it's morning for everybody here. It's definitely morning for me, but okay. The problems: non-finality confirmations are required. Fork as possible. What kind of instructional is this? Okay, so I don't know. I don't understand what this is supposed to be all about. The solution? Okay, the problem: non-finality confirmations are required. Fork as possible. Low throughput. Long block time. Low transactions per second. Ethash Ghost can only support 3 to 5, 15 seconds per block. Lack of governance. Too open. Every node can be a miner. Extra effort are required for blockchain management. High power consumption. Miners are competing on blockchain generation. The solution: practical Byzantine fault tolerance. Miguel Castro and Barbara Liskov, 1999, targeting at a Byzantine fault tolerance NFS service in an asynchronous system like internet. A state machine replication algorithm. Go Ethereum integration. NCCU BFT. Oh my God, dude, this is probably the worst explainer I've ever seen in my life. Why don't we go and find something better? First, let's just look at Byzantine fault. I hit caps lock somewhere. Byzantine fault tolerance, and I will go into images because sometimes you can find some really good images, and from there you tend to find some of the best articles. Like this image right here shows a good depiction. Okay, all right, so let's go to right here. Ta-da, ta-da, ta-da. And practical Byzantine fault tolerance. Okay, what is the Byzantine general's problem? The Byzantine, what's his problem, man? The Byzantine, that's the way I read it. Hey, man, what's your problem? The Byzantine general's problem is formulated differently in various sources, but no meaning changes were issued, only the stylistic ones. Byzantine, the night before the Great Battle. Byzantium, the night before the Great Battle. The Byzantine army consists of legions, a number of legions, each commanded by its general. Okay, and it looks like they're all trying to attack the castle. The army also has a commander-in-chief to whom the generals obey. At the same time, the Byzantine Empire is in decline, and any of the generals and even the commander-in-chief may be traitors. Interested in the defeat of Byzantine, one of the generals gets the leader of the order course of action at 10 a.m. The time is same for all and known in advance, namely attack the enemy or retreat. The possible outcomes of the battle is if all the faithful generals attack Byzantium, it will destroy the enemy, favorable outcome. Or if all the favorable generals retreat, Byzantium will retain its army, intermediate, that's a neutral outcome. And if some loyal generals attack and some retreat, the enemy will destroy the entire army of Byzantium, unfavorable outcome. And it's basically coordination. It takes coordination in order and teamwork to be able to do something that seems nearly impossible. And if you know anything about Byzantine history and the Theodosian walls and the city of Constantinople and stuff like that, you will know that those walls seemed at the time completely impenetrable. You had not just one wall around the castle, but you had two more outer ring walls. I believe one was 10 meters, one was 40 meters, and then the one closest to the castle was 80 meters tall, and meters are roughly about 3 feet per 1 meter. So you can imagine that's really tall, and it's all on a hill. And then one side of the castle is completely facing the sea. So yeah, it's not the easiest castle to try to defeat. So it definitely would take some coordination. Hey, what's up, N81? Nice to see you this morning as well. So yeah, I mean, it's just... the Byzantines generals did have a problem, and without some kind of coordination, and I guess the generals surrounding the castle over here would represent nodes. Let me put this over here so you can see it better. Okay, so if you had some corrupted nodes, then obviously that would lead into defeat as they dump all that molten hot tar and lava on all the people trying to climb the wall, and be pretty gruesome. And people think, oh, they're just arrows and stuff. They had ballistic missiles that could completely shoot through armor, and you think it's no big deal, and let's just use a shield. No, they had some very amazing missile technology back then, and not necessarily missiles that we know as propelled by jet fuel, but propelled by kinetic force. So yeah, so interesting stuff here. This is in relation to the cryptocurrency industry. Okay, so the Byzantine fault tolerance description. Let's go back up here now that we looked at the problem. Practical Byzantine fault tolerance is a specific case in the optimization of the Byzantine fault tolerance network ability. Byzantine fault tolerance is the ability of a network to unmistakably reach a consensus despite malicious nodes, those bad generals out there, attempts to propagate false data to other peers. This ability is crucially important for the distributed networks to prevent the spread of mistakes and incorrect information that is sent by malicious or broken nodes. Networks that are not Byzantine fault tolerant, if they have no sufficient consensus on the status of the nodes, so that they are either Byzantine fault tolerant or not, and if they don't have sufficient consensus of the nodes, then they're basically not Byzantine fault tolerant. So for example, a server broke down and is spreading incorrect data. In a Byzantine fault tolerant network, the consensus remains between the nodes that are still functioning correctly. And so data spread by the broken servers is not corresponding with the data of the other network's participants and does not affect its maintenance. The failure detecting systems in such network will detect its problem and restrict it from the further operating. In a Byzantine failure, this server will be seen differently by different nodes. Some nodes will consider it fully functioning and continue gathering its info. It would be hard to automatically shut down the server due to lack of consensus between the participants on its condition. So this idea in modern term is derived from the Byzantine general's problem, and I just kind of went through that here with the generals trying to surround the castle and them all needing coordination. In relation to cryptocurrency, PBFT can be an alternative or addition to the proof of work consensus mechanism. Basically, it prevents 51% attacks, which is where 51% of the nodes are overtaken by malicious actors, and therefore they can influence decisions made on the network and create forks or transactions that go towards basically line the pockets of whoever has corrupted the network. So while Bitcoin reaches Byzantine fault tolerance with its proof of work, it has many downsides. Bitcoin consensus demands large energy consumption and is difficult to scale and not very fast. In PBFT networks, there is no need to validate each transaction as all the nodes of the network are in consensus in the overall state of the network. It makes PBFT significantly less computationally intensive and therefore less energy demanding. However, PBFT requires high level of communication between the nodes, which leads to the limitations in terms of the size of network that can be governed with PBFT. Smaller possible sizes of such networks can lead to the Sybil attack, an attack performed with forging a large number of entities in the network to take over 1/3 of the network. So Sybil attacks and 51% attacks are closely related, but Sybil attacks are done by somebody or a bot creating tons of different IDs and from various IP addresses or whatever, and being able to overtake the network that way and influencing over 1/3 of the network by multiple IDs coming from one source. With some additional features, PBFT is implemented in the Zilliqa cryptocurrency and in the Hyperledger project. PBFT and Hyperledger is used to provide its projects with additional scalability, and in Zilliqa to provide high transaction speed per second indicator by combining PBFT with traditional proof of work. So interesting stuff, man. Well, to me anyway. And so, what's up, 29 LH06 as well. There's just a lot of stuff to learn. I'm, like I said, putting together this little video about blockchain programming languages. And to me, programming languages are interesting. Programming has been around forever. And you think about it in ancient times, and you think about law. You think about covenants, even in the Bible, the Abrahamic covenant, the Noah's covenant, the Davidic covenant, and then, of course, the one we know all, the Genesis covenant, and the one everybody knows about with Jesus. I mean, these are all covenants and codes and algorithms in a way for future engagement for people to follow. And then you have, after that, you have during that time you had Roman law, you have the Justinian codes, and then you have La Ley de las Siete Partidas in Spain and around the 10th or 11th century. And all these are basically algorithms set in place and protocols for people to follow to behave in a certain way for society to function in any possible scenario that they could think of. And they were written by people with large macro thinking in mind, and they had to write possible protocols for just about every single situation that could hypothetically happen. And the priests and the scribes were the ones that implemented this in code. Basically, written language at the time seemed to be code. If I'm thinking right about this, I'm kind of brainstorming as I go along here. And when you think about it, like Latin, only the priests knew Latin. And during the Roman Empire, much of the Roman Empire spoke Greek and other languages, but the law was written in Latin. And then afterwards, in the medieval times, most of the law was written in Latin, and only the clergy people, and a bunch of the clergy people didn't even really know how to read Latin themselves, honestly. But they would get up there and they would go in their church services, and the peasants would be sitting in their pews, and there would be a huge space, sometimes the length of pretty large rooms with gold or bronze gates in between the clergy people and the peasants, and they're up there reading the sacred texts that they that their society is formed on in Latin, and none of the peasants could actually understand them, but they trusted that these people were reading the law and the code and the procedure of which society should be governed by. And that was kind of the protocol set. And they ascribed a divine status to this. It created a system of trust that transcended humans. And human beings and emperors would do this too. You had some friendly, down to earth, people-pleasing Roman emperors. But then it eventually ended up going to where nobody could even see or talk to the emperor, and they were very removed from everyday humanity. And this is done on purpose in order to create kind of a mystique and a transcendence about law and code, and a divine status to it. Diocletian did this as well as a Roman emperor, created himself a kind of a divine status that was untouchable. So all these protocols would be enacted not by human but divine authority. And nowadays it seems it's being done by math. And programs and protocols are being automated. And they're written in languages that are not really legible to the average human person unless they really dig in and study it. And fortunately, just about anybody has access to be able to study programming languages. In a way, sometimes people put some divine status on programming languages, but fortunately, we have the freedom to go in and learn our own idea of programming languages, and learn C++ and learn Go and Java and Solidity and JavaScript. So it allows us the freedom to go in and maybe take an audit of some of these things coming out. But what we're doing is creating DAOs, and we're creating blockchain programs in smart contracts in order to automate decisions for us, and hypothetical law and programs of what to do in hypothetical situations, and with our finances as well. It's kind of in a way, Innate One says some politicians are doing it in our time. Yes, and politicians now, especially with the implementation of the blockchain and artificial intelligence, and you see things like Fetch AI, we're going to be making ourselves obsolete, including politicians. And especially once DAOs start kind of becoming the norm rather than the exception, AI can take over, and then they can start to decide, what runs the most efficient society. And it's a little dystopian in a way if you think about it like that. But yeah, it's truly a fascinating subject. And you also have to think about who is initially writing these programs and what kind of biases that they might have, because a lot of times the protocols don't give opinions. They just they provide algorithms for how to handle not necessarily specific situations, but situations as a whole. And yeah, so that's interesting thing about programming. Like I said, I'm not on a script. I'm trying to think about this as I go along. So if anybody has any ideas, definitely chime in. But I'm doing research right now to create little blurbs on this type of stuff. Any articles that you guys might have would definitely be helpful. But yeah, I'm going to talk a little bit about, I'm going to try to keep it to 6 minutes, just about programming languages and that are used in the blockchain world. And I'm going to try not to go down my long rant about Justinian law or Diocletian or any of that. I just want to keep it simple. But there's just so much to say, and we're almost kind of creating as developers a new form of priesthood. And yeah, that's why it's really important that everybody, if they don't learn how to program, should at least learn what it's about and how it can affect the world around them, and it kind of take away the mystique of the developer a little bit, and realize that the biases and things that they can write into the code. And then now with AI sitting on top of it, once code is written and then AI bots start talking to each other and then writing their own code from the code that they've been written in, at what point do we become obsolete? And not only obsolete, but part of the problem. So, I know we're going down a real deep dystopian sci-fi path at this point, but yeah, it's just all things need to be considered. So yeah, and 8.1 says everyone needs to keep their own sovereignty. Yes, absolutely. And part of keeping your own sovereignty is learning about programming and learning to read and audit your own code. So that's kind of what I'm trying to do. I'm not necessarily looking to go out and write smart contracts and develop blockchains myself, but I do want to understand it. And there are ways to understand it, and there are good learning resources. Komodo is actually coming out with a blockchain drag and drop type of blockchain builder. There's the Cardano Marlowe Playground that can help you build your own smart contracts. Let me see. Marlowe. So it kind of will give you a visual representation about how some smart contracts are done. Let's see here. Marlowe Playground, iohkdev.io. So right here, yeah, you can start with Marlowe or Blockly. Yeah, so let's go to the simulator. Ready to go, start a new project. Ta-da, let's do Blockly. All right. So yeah, you can drag and drop pieces of contracts, and let's open an example. Let's just take one with escrow with collateral. We'll do it with Blockly right here. Okay, so yeah, you can drag and drop little pieces of the smart contract and put them where you want, and it just will kind of help you see the overall macro picture if that's how you learn. Some people learn from the bottom up, micro to macro. Other people learn from macro to micro. What is that? Aristotelian versus Platonic thought. I don't know too much about philosophy, but that's kind of where it goes, and different approaches to the same things. Do you see the parade from the actual crowd or from on top of the hill? So yeah, this is kind of a way to learn how to build smart contracts. Then you can go deeper and deeper, and if you want to stick with Cardano, you could learn Haskell, or if you want to learn other languages, yeah, there's all types of languages you can learn here. C++, Golang, Java. Java is a really important one because there's so much built on top of Java. I actually started a master's of computer information systems for a while, and then I ran out of money. This is about 15 years ago, but I started learning Java, and it is an amazing language. A lot of stuff built on it. And Solidity is basically like JavaScript. So if you have any web development experience, and you've had to even if you've just copied and pasted JavaScript into front end HTML, then you might be able to understand Solidity pretty easy. So. And then some of the more, I believe Komodo is built on Rust, and a lot of really great modern cryptocurrency projects are built on Rust. I believe the Cosmos ecosystem is built on Rust as well. So, yeah, Golang. I don't really. Oh, is Golang Cosmos is built on Golang? Oh, okay, all right. So yeah, I got a lot of stuff to learn here. So. Yeah, watch out for this stuff. I'll start, working on these videos with these people, and like I said, I'm not shilling any particular projects because I'm not getting paid by anybody. But I'm definitely I believe that you learn by teaching, and this is a way for me, like I said, to cross market myself and Komodo as well, and to learn some stuff in the process. So, yeah. Always keep learning. Yeah. Well, that being said, I did want to also go over real quickly Decentralization Central here, and I know I did a few days ago, but there's this one thing specifically on here, Bitwage, and I know I barely touched the surface on it, but I have a couple. Oh no, I don't have a couple minutes. I always get to Bitwage at the last minute. But look this up. I think I'm going to probably use this with my company. It allows you to be paid in cryptocurrency from your company without them having to be set up in any way, shape, or form with a crypto wallet or anything. All you do is give them the Bitwage banking details, and then they direct deposit into Bitwage, and you can specify your allocation of what percentage of your paycheck you want in cryptos, what specific cryptocurrencies you want them in, because they give you a list, and there's a pretty good variety. So yeah, it's definitely something to look at. So I'm probably going to look into this as well. And then see here, N81 says, any thoughts on ADA Cardano? Yeah, Cardano, man, I just want them to hurry up and come out with something already. I mean, it's been a lot of talk. I think it's a great project. I have an investment in Cardano. I have a good chunk of Cardano delegated to a pool, and I have it to the Buzz pool, BUZZ. And I've gotten a pretty good, decent return on it. It is fast, it's cheap, it's easy to use. There's a lot of good things about Cardano. I mean, I just showed you this Marlowe playground. It allows anybody to create smart contracts really easily using a drag and drop system. So it could be used in a way that let's say, for instance, you're a photographer and you want to do some wedding photos, and it will help you create a smart contract with your customer, as a small business, rather than needing to, because a lot of people think of large companies being the ones to be the only people qualified to use blockchain and smart contracts. And that's not necessarily true when you implement a system like this. And I know Unibright is also doing drag and drop style smart contracts as well, but they're more geared towards large enterprises. So I think Cardano kind of allows the average Joe to jump into the blockchain world. And they're real focused on Africa as well, allowing them access to the rest of the outside world outside of their warlords. So yeah, interesting stuff going on with Cardano. I just wish that they would hurry up and do something. I want them to create a DEX. I want them to create they're almost about to roll out their NFT platform. I believe people are already creating NFTs on there. Cardano Buzz is, and with Cardano Kids. Yeah, Cardano Kids as well. That's with a Z at the end. And there's a lot of stuff coming out, but yeah, we'll see. Hey, what's up, Randy Detre? Yeah, I'm sorry if I mispronounced your name, man. All right, well, I got to go. I've been going on for 35 minutes now. I can't believe it. And I'm going to be interviewing somebody this Sunday, so be sure to tune in. We're going to be talking about digital ID, and this person is a veteran in the traditional finance and banking sector. They're going to remain anonymous, but yeah, I met them in the Defiant Discord chat. So it should be an interesting conversation. We're going to be talking about proof of humanity and digital ID. So be sure to tune in then. And in the meantime, I'm going to be working on creating some of these other videos for the Komodo Blockchain Academy. So, all right, man. Well, I will talk to you guys tomorrow. Bye.